See, it says you streamed 3 hours ago.
Yeah, that was some lectures or some presentations. You still don't see this one?
Refreshing. Yep, I see it.
Okay, showing. All right, class. Let me check my board out. Hopefully we be in good shape to start writing. Cause I see this. When I see this, this gives me hope. And I see this right here. That gives me a little hope. Come on, come on. Yeah, approaching the end of the use of life. Don't have no touch. Touch. Oh, nothing. Oh, they have the software. Dang. Nothing. Let me check it again. See what this says.
Is the pin on, like the pin itself?
I'm trying to do the calibration, it's not doing anything. See here? None of this is working. Okay, let's see. See, no, I think I could write here, but I can't write here. Yes, oh, right. See, I can write with the computer, but I can't get you to the board and write. You see what I'm saying? And see, apparently the board is not connected some kind of way. I have to get them to check that out. It's there, the software is there. But normally I should be able to calibrate. None of this stuff is working. It's not connected to the board. All right, so we're not gonna worry about it for now. So let's get into our notes, okay? Anybody got any questions about the conversions? Questions? Everybody straight, everybody ready to roll.
You need to close the window.
Close that lid. All right, thank you. Okay. All right. So we in chapter 3. So let's talk about modules, okay? What are modules? Anybody can tell me what a module is?
Group of statements that exist within
Go ahead, read it. Miss what? Miss who?
Sterling.
Sterling. What it says?
Module is a group of statements that exist within a program for the purpose of performing a specific task.
And that's all that a module is. What is it? What's happening is, or what has happened, you have written programs, right, that has all the statements where? Within the main function, correct? Int main, and then whatever it is you're gonna do, correct? Whenever you start writing code and using modules, what you're gonna start doing is breaking up your code so that you can say, okay, I have this code here, I wanna execute it, but then I may wanna execute it any number of times, but I don't wanna have to keep what? Rewriting it in my program. I could just simply what? Call it, and it performs that action, all right? So, Let me give you an example so you can kind of visualize what I'm talking about. Say we go to online GDB. Okay, let's go to online GDB. In online GDB, okay, let's choose C++. All right, and then I'll select all of this and wipe it out. So I'll do pound include IO stream. And then we'll have something like this. 0. Correct? Now, in short, we can do int. Well, I can't do it here. What I'll do, I'll make it global. We never talked about variables yet, but what I'm going to do, I'm going to create variables outside of the main function. What that does before the main function, that will make that variable global. All right? Now, what's a global variable? What's a local variable? Let me ask you this question. If somebody was an entertainer and they was known locally, they are only known to who? The people in that particular area. If somebody was an entertainer and they were known globally, they're known what? Worldwide. Okay. So that's the concept of global and local. A global variable is only known within that scope, all right, of that main. Okay, if I put that statement inside of here, int x, x will only be known within that main function. And if I have other functions, it's not known to, the x will not be known to those other functions. I'd have to pass the value some type of way. If I did something like this though, int x, now x is what? Global. Now it can be known, it is known by what? And can be used anywhere in the program. It's globally available to me. All right? So that's the difference. So what I'm gonna do, I'm gonna globally declare or initialize two variables and declare one. Int x equals 5, y equals 3, and total. All right? Right? So these variables can be used throughout. But what I'm gonna do here is, I'm gonna do something like this. I'm gonna say, okay, I want to add x and y and get a result. But then I also want to multiply x and y and get a result, right? Now that's two different tasks, right? I could do them together, right? No problem. But what I'm gonna do, I'm gonna separate them in modules. So what I'm gonna do, I'm gonna create an add module that I have to define. I have to say void add, and I'm not passing any variables, void multiply. And I don't think these are keywords. Now, so, yes ma'am.
The void,
That
means it's putting it there, but it's not gonna show it in the program?
No, that means that there's no type of argument or value that's gonna be returned. Look here, I got what? This function is what? Int main.
And it's gonna
Return an integer of 0.
So voids just don't need.
You're right, you're not returning any values. You don't need the word return in your function, all right? Because I could have done int add. So that means what? Once I'm complete my or anywhere within my function, I have to return an int value, all right? So here I declared the variable, the functions that I'm gonna use. Here I'm gonna define what the add function is gonna do. So I'll do void add, open close, if I can do it. And now, just like my main function, I don't put a semicolon, and I'll just do something like total is equal to x plus y, right? Because this is the add function, right? And then see out I want to say total. All right, now void multiply. All right, I'm defining it so I don't put semicolons. And what I'm gonna do, I'm gonna copy this, but you got to make sure when you copy something that you go back and modify it to take everything that you have to remove out. So here we're not adding, we're multiplying, and here we're not getting a total sum, we're getting a product, right? All right, but we still outputting total, all right? Now, looking at this, what was our, and then two, just because I defined the functions, now in my main function, I need to call them. So I'll just do add, and then multiply. All right? Now, if you look at this, this is pretty much declaring the function, telling the compiler, I'm gonna have a function called add, I'm gonna have a function called multiply, and they're not returning any variables or values, and they're not passing any variables or values. Here I'm saying, I'm defining what the add function is to be doing. All right, it's taking x and y, adding it, putting in the total, and I'm printing out the total sum, and then total. Here I'm defining what the multiplication function is to be doing. It's gonna take the two values, all right, and x and y, multiply them and store them in the total, and then print the product of those two. But in the main, it says what I'm gonna do first. What I'm doing first in the main? I'm calling the add function. You understand? Then I'm calling the what? Multiplication function. So let's run this and see what happens. Hopefully I got all the errors out. Oh, I got an error. It said unexpected at the main.
Multiply, you see right there, you're missing. Right
Oh, my open curly break. Parenthesis. All right. And it said expected a semicolon. All right. So let's run it again. Oh, I got two up now. Why? All right. So let's run it. Look here. What? It did what? What's in the main, class? What's in the main function? Do we have a assignment statement in the main function? Huh? No. Do we have an output statement in the main function? So all our executable statements are pretty much in what? Our process statements are where? And input out are in our functions. What's the definition of a function or module? Well, I'm gonna go back here.
Group statements.
Right. It's a group of statements, right, that exist within a program for the purpose of performing a particular or a certain task. And you can see that in what we did, right? What we did, we said, okay, we got two numbers. In this for a function, we're gonna add them and print the results. In this function, we're gonna multiply them and print the results. Everybody understand that? Everybody got it? Now, the thing is, what if I do this, class? Well, I'm not that yet. Do this. What if I do this? What happens?
Multiply first.
It does the multiplication first, then the add. So what? If add was 50 statements, the add function, The multiplication was 200 statements, and I needed to reverse the order in which my program was to be executed. To execute, all I need to do is what? Reverse the two codes. You see how simple that would be when you have your program broken down? But if you didn't, you'd have to say, oh, let me grab this. Now I need to go find exactly where I need to insert it. And then you could what? Run into some issue, right? So now, when I run this, now it's going to have what? The product of 5 times 3 before the sum of 5 plus 3, right? Now, this is another beauty of writing code in modules. If I do this, what happens? Correct. So I don't have to repeat my code what? Over and over again. I could call it as many times as I need to. Correct? That same exact code, I'll just call it when I need to call it. So I don't have to have in my program the exact same statements multiple times in my code. Everybody kind of understand what modules are and the purpose for them, right? And what happens in the main function? It kind of simplifies the main function to what? Kind of tell you in a generic aspect, okay, we multiplying here, we adding here, and we multiplying here, right? Rather than have statements where you got to look through it to see what's going on or whatever. We multiplying, we adding, and we multiplying, right?
So you're using like the voids and the stuff outside of the main function to basically establish as much as you can, so that when you go to the main function, you just tell it to use that other.
Correct. That's right. Correct. Right. And when you start programming in that fashion, you're being more efficient. Because what happens is when you have to build onto your program, you don't have to start what? Figuring out where I'm gonna insert whatever. Then you got curly braces, in depth, and like, wow, wait a minute, what's going on? Where, whatever, how, right? Okay. All right. So now that you kind of got a gist of it, let's kind of go through the notes, okay? If I can get to them. All right. So it says that in chapter 1, you learn that a program is a set of instructions that a computer follows to perform a task, right? Then in chapter 2, we saw that simple program that performed a task for calculating an employee pay, right? Recall that the program multiplied the number of hours that the employee worked by the employee's hourly pay rate. Okay? A more realistic payroll program, however, would do much more, and we know that, than this. Okay? In a real world application, the overall task of calculating an employee's pay would consist of several tasks, such as retrieving the employee's hourly rate, getting and retrieving the hours worked, calculating the gross pay, calculating the overtime pay, calculating withholdings, whatever it is, taxes and other type benefits. Then you have to calculate the net pay by deducting from the gross those taxes and benefits, and then printing out the paycheck. So what you would do is what? Take each one of these different processes, what? And put them in modules. So what? Whenever I want to do something, I call that module, right? Because you done broke it down into what task is being performed. Now you can say, okay, when I'm doing the gross pay, okay, I'll go to that function and do the gross pay. When I'm doing overtime, call that function, I'll do overtime pay. But you may have some other code in your main to determine which function you're gonna go to. Because what? If my regular pay or my regular or base work week is 40 hours and I'm doing overtime based on 40 hours, then what? If a person worked 20 hours, do we need to go and calculate overtime pay?
No.
You understand? Overtime pay would be what? 0. You understand? So you may have an if statement to determine whether or not you're going to execute it. Yes, sir.
It does differ by workplace. My workplace
Right.
ran overtime after 8 hours on the clock.
8 hours, right? And you know, a lot of that varies, cause different companies do it, and then you got federal companies that are federal funded companies. They may do it different, cause what? Holiday pay, they may get double time or 2.5, depending. So it just depends on the environment that you work in. Some companies don't even give you what. Yeah, you just work 80, 90 hours and you're getting straight time. It just depends on the environment or the company that you're working in. All right? But like you say though, as a programmer though, if we were designing a payroll application for a company, we would have to sit down with the person who actually calculate the books for the payroll and find out the gist of how they calculate it, right? So that when we complete our project, it's done in the manner that they do business, right? Because otherwise you'd be, a boss say, well, I don't pay overtime, whatever, and you done created this program, and all of a sudden he don't realize that he got 20 employees that done work 20 or more overtime hours, and you done gave them time and a half, and it done ballooned his regular payroll by 2.5 times, and he might not have that in the bank to pay, right? But you done cut the check because the software done ran through and cut the check, and all of a sudden now the checks are bouncing. So you got to be able to work with the companies to get everything in order. So now most programs perform tasks that are large enough to be broken down into several subtasks. And like I said, when you write code, normally we write small programs, but sometimes I just may give you a program that you're able to break down. All right? So let's say for this reason, programmers usually break down their programs into modules. All right? A module, again, is a group of statements that exist within a program for the purpose of performing a specific task. Now, this approach is sometimes called divide and conquer, because what you're trying to do is if you've written out the whole logic, all right, you want to divide the code up so that you can say, okay, this code performing this task, this part is performing this task, this one, etc. So it's somewhat called divide and conquer. All right, so you're breaking a larger piece to make smaller pieces. All right. Now, and it tells us when we talk about, you might have modules to do each one of those steps in that overtime pay. Now, modules, once you create your modules, you can call them in any order that you want to. Okay? Everybody understand that? Modules don't have to be called in the order that they are declared, except, they got one exception. As we know, there's more than one way to write code and get it right. Right, class? It's all in programmer style. What could happen is, you see I have void and void multiply? I could comment these out, okay? And then what I can do, I could go here and take these functions that are defined, and I can paste them here. Totally legit. All right? It's like when you define the statement, define a function prior to the main, then you don't have to give its prototype, okay? Because it's being defined, it's almost like initializing a variable. All right? When I define that function, it's like me, I'm initializing. This is what this function is doing. I'm introducing it, and I'm telling what it does. The only problem with that is when you have local variables and whatnot, and even I think this statement here, if I had this prior to this statement, it would not know what X and Y is and total. You understand what I'm saying? So it does matter the order in which you put it in. Now, it may not matter in the order in which I list them now, but it can. I've seen my students running the headaches trying to code this way rather than use the prototype, because this function the value in this function was dependent on the value in this one, but they defined it before they defined the other one. It's okay if you use prototypes and put the functions at the end, you won't have any issue. But when you start defining them above the main, then they have to be in that logical order so that it'll know what's going to be the value. When I move to the next one, oh, okay, I know what value, and I move to the next one. Okay, so you gotta watch. Programming style, it doesn't matter. It's still gonna work. If I run it, I'm still gonna get the same. Oh, well, say run there. Hold on, wait. Void add. Yeah, we defined it void add. Oh, I copied it. I didn't cut it. Okay. Let's see something. So I got it twice. That's why. So what I'm gonna do? I'm gonna slash asterisk. Asterisk flag, right? So when I run it now, see? Same thing, right? It's at the top, it's defined at the top, and it's gonna still call the functions or whatever. But all that's programmer style, right? Programmer style. Now, back to the program. Okay. So, what are some benefits of using modules? Simplify the code. Remember, we're in the main, we multiplying and we multiplying. So you kind of get a gist of what's going on with the code, right? Code can be what? Reused. We could call that function as many times as we want, right? Don't have to keep what? Rewriting the same code over and over and over and over again. And what? It helps you to better test your program, all right? Because what? If I know I have an issue with what? My multiplication results, what I need to look? In that module, right? I have to look through the whole program. Look to that module, as the first step, right? So you kind of can pinpoint where some logical errors could be, right? Without having to try to what? Go and decipher the whole program. All right? So here it's showing you previously, this is the way we wrote code, right? Straight down, just from first sentence to statement to the last statement. But when you write with modules, you might break down all these statements into 2, 3, 4, etc. number of modules, right? So that you can call them when you need them, right? Everybody understand that? So it's broken up into modules, all right? It allows you to pretty much develop code faster. Now, as an individual, it might be and might not be as fast, but say if we had a project and as a group, as several groups, we were working on this project. And say we had 2 or 3 people on this side of the room in a group working on, say, the addition part, adding the 2 numbers and doing whatever. They could be working on that while somebody working on the multiplication, while somebody working on whatever, and then what? Once everybody finished, we bring it together and we test it, right? So you can be working on multiple pieces at one time and complete the project in a faster time. So that's all they pretty much saying, all right? Because and just like when you're using the Microsoft Windows, they had to have, that was a project that many groups of people worked on. Some may have worked on the network side of the operating system. Some may have worked on the system administrative side of the operating system. Some may have worked on the error messages of the operating system. Some may have worked on some dealing with the utility packages with the so everybody worked on their different parts, but then eventually it came all together and you put it together and you have one big project. All right? So, and then it says easier facilitation to teamwork, and that's what I'm mentioning, where everybody can be working on the different projects and then bring it in as one, right? And the team working on their project can test and test and test and test, get it just so, but then you got to bring it all together to test it all as one to make sure that everybody's pieces work in unison. All right? So that's pretty much what modules is. Defining a module. We pretty much did that. Defining a module is actually typing inside the function what it is it's supposed to do. All right? The code of a module is known as the module definition. If we were to look at this, all right? Let me close this up. Let me minimize it. We look at this and we look at add, right? Look at this. What is the definition of the add function?
X plus y.
Huh?
X plus y.
Total is equal to x plus y, C out, sum total. Whatever it is that is to be done within that function, that's its definition. Everybody got that, right? That's the function definition. So if I told you to write a function definition, including the function header and the body with the curly braces, write a function definition that will output your name, your major, and the semester, what it should look like. Void, and whatever you want to give it, like semester, open, close parentheses, right? And then open curly braces, then what? See out your name, see out your major, see out the semester, close curly braces. Whatever is specified to do, that's the definition. Everybody understand that? That's the definition of the function. You're defining that function, what it is to do. All right? So, if I ask you, what's the definition of the main function? What is the main function defined to do?
Multiply, add, and multiply.
Call the multiply function, call the add function, and call the multiply function again. Right? Now, what is the add function doing? We don't know, right? But we know that it's calling the add function, it's calling the multiply function, right? And that's the definition. All right, so if we go back to the notes, okay, a module name. A module name is a user what? Identifier. Just like a variable name is a what? User identifier. You, the programmer, create these names when you create the program, right? So, the naming of a module would be, you would use the same guidelines and rules as you would for a variable. So what were the guidelines for creating a variable?
Number can't be first.
Can't have a number at the beginning.
No special character.
No special characters.
Case sensitive.
Huh?
Case sensitive. No.
Can't have a space.
No spaces. It must be one word. So the same thing holds true for a module, right? Now, sometimes what programmers will do, they'll say, okay, all of my functions, I'll just make them all uppercase. You know what I'm saying? So when they're looking at their code, they'll say, oh, okay, this here is a module. All right? All right? So they'll say, okay, when they're looking at a program, they say, oh, void, oh, okay, that's a module. When they look in here, oh, module. And if they see it anywhere in the code somewhere else, oh, it's a module. But that's just like a signature. That's their signature. They do that every time, so they recognize. And it's either once you create patterns or signatures or style, it makes it much easier for you to decode your program because you know what you did, where, and why. You understand what I'm saying? So, like I say, eventually you will evolve to having a programmer style. Okay. All right, but right or wrong, it doesn't matter how you do it. But a lot of times when you get a job with a company, that company, the software development team or either the area might have certain rules in creating functions, creating user identifiers, in that, not say the rule for validity, but the rule so that when they look at something in your code, oh, this is such and such. Oh, this is such and such. It's easy to pick out and see what should be going on at certain time. All right? So that's all that's for. Now, so the module name, like I say, just like one word, no problem. But it still can't be a reserved word. Now, defining and calling a module. So, when we look at this, we said this is where we what? Defined it, right? Void, add, and whatever it was supposed to be doing, correct? That's defining. But look here, in main, when we said multiply, we just, in the open close parentheses and the semicolon, that's where we calling it. We want to execute it. We say go and get those statements and execute those statements and then return back once finished. This is the calls. This is a call to call multiply. This is a call to call the add. This is a call to call multiply a second time. All right? So the function definition is what it is to be doing. All right? What it's going to be doing. The function call is the statement that says, okay, go out and call that function and execute it. All right? Everybody understand it? All right. So, now, if we look in here, same example we give, module name. That's like putting an add right here, and then open, close, and then the statements, and then what? Well, the curly braces, and then the close curly braces. All right? The first line of the module header, all right, here, this is called the function header. All right? If we look at this program here, int main, that's a function header. Main is a function, right? If we look here, void add, open close parentheses, that's a function header, right? We look at void multiply, open close parentheses, that's a function header. And then here's the body, here's the body, here is the body, right? Everybody see that? Right? So hopefully you learn that, and when you understand that, it makes it much easier to write code dealing with functions. All right? Now, and so it goes on, and it talks about the parentheses. And like I say, later on we're gonna start listing arguments and certain type arguments so that you can see how we could take a variable, a global value from a function and pass it to another function to be used, all right? But we'll do that at a later time. But look here, module, this is the module name, which is what? Show message. What is the definition of show message? Display hello world. That's all it's doing. What it's supposed to be doing? Printing out hello world. That's it. All right? So that's the definition. All right? All right. Now, and like I say, calling a module, you don't have void or anything in front of it. You just have the function name and the curly open and close parentheses. But then if we had arguments, you would have your argument list. But we're not dealing with that at this time. All right? So, let's look at this program. All right? And what we'll do, I'm gonna move it over some, all right, and I'll choose this one. So let's look at what's going on here. What's going on in this module? It says module main, right? So that's like saying what in our program? Normally we have what in our program? With main. Int main, right? So that's just like our int main. So in our main function, what we doing? What's this saying? Display, so we're doing what? We see out. We outputting that value, right? We outputting, I have a message for you. But then look, it says call, what function is it calling? Show message, right? So it's gonna call show message, and then once it go to show message, execute show message, it's gonna return back and say what? Huh? It's gonna do what? Hello world. It's gonna what? What's the statement after show message?
That's all, folks.
That's all, folks. You understand? So that's what's gonna happen. So let's take that example and let's use it here. So what I'm gonna do, I'm gonna erase all of this information here, all right? And so if we wanted to take this, all right, and put it in a program, because this is pseudocode, right? So we will do our int, and being that we already have part of our shell, we'll do int, that's cap, int main, right? And then what? Open curly braces, return 0, all right? But what's defined in here? We say what? Display, so that would be what? See out, right? I'm gonna just go a new line. I have a message for you. Right? Now, so after that, it says what? Call show message. Now, I cannot just call a function and not have it what? Defined, right? Right, class? So, but I could put it in my code without running it first. I could do what? Show message, open, close, semicolon. Now, let me set my prototype up here. I'll say void show message. Now I need to also what? Define my function, what show message is gonna do. So I'll do void and what message y'all want to output? I want to give it. What's the message? Huh?
It really is hello world.
It's all, folks.
No, but that's gonna be
It's
after.
hello world.
Oh, that's what it actually is. Okay, so let's put hello world. All right, hello world. All right. Now, so that's all that's going here, right? That's all it's doing. Print out hello world, right? But then back in the main function, after we call message, we want to do what?
See out.
See out or display right? Right, Claire? Right. So, if we run this, hopefully all errors are gone. See what it did? Let me pick this up. I have a message for you. Display, I have a message for you. Then call what? Show message. What's show message defined to do? Print out what? Hello world. That's all it's defined to do. It could be a whole lot of other things that could have been defined to do, but that's all it was defined to do. Then we return back to the main function after it completed the show message, and we outputted what? That's all, folks. Everybody understand that? So that's what that function did. All right? All right. So, now, and basically what? Same output that they got, correct? Same exact thing. All right, so here, it tells us the main function, int main, whatever, display, I have a message, call, show message, then display, that's all, folks. And we ended the main, all right? And look, the module for show message is outside of the main, is defined outside of the main as to what it is to do. Alright? So now, let's look at, okay, that's basically the same thing. It's showing you, again, it's coming out of here, executing that, and then it returns to that very next line, right? So when I call show message, it goes and executes these statements, but then it returns back and executes the very next line, executable line in that main function. All right? Now, to flowchart modules, okay? When you flowchart modules, this is what you would use. This is the symbol you use for module, all right? It's the process symbol, but you have the two lines on each side with the name inside, okay? Now, another key point when you flowcharting, when your flowchart consists of modules is your modules all your modules will have a start and a stop terminal, all right? Or a begin and an end terminal. But you won't have begin in the starting terminal. You'll have the name of the function because you begin with the main function, all right? Then you would not have end in the ending terminal of the function. You would have what? Return, where you know it's returning back to the what? Calling function. Everybody understand that? So if you want to flowchart a program that had a module in it, here is the main program. Here is where we call in the module. What's being done in the show message function? We don't know in the main flowchart. We have to go to the what? The flowchart that shows the show message function and see what is actually being done. Everybody get that? Right? Everybody get that? All right, and then you're gonna end in the main function is gonna always be your end, regardless if you stop and executing or whatever, but your end is always in the main function. Because the main function has that begin and end curly break. All right? So, top-down design. In this section, we have discussed and demonstrated how modules work, okay? You have seen how a computer jumps to a module, okay, when it is called, and return to the part of the program that calls the module when the module ends, okay? It is important that you understand that these mechanical aspects, or understand these mechanical aspects of a module. When that function call is hit, it leaves and go and execute those statements in that module. Then once it completes that module, it returns back to the calling function and then start execution all over again. Now you might say, well, why is that so important? The reason being is because I could have a main function that calls A. I'm gonna put call, but I call A. All right, A is a function, whatever that function is. But then down here I have void A, and A will call. That's wrong. A will call B. You understand what's happening here? And then void, not lowercase, B, and then B could call C, right? And then let's say void C, and we do whatever. Now, so what just happened here, class? We started out in the main function and we went where? From the main where? To what function? We left out the main and went to what function? Huh? A. We went to A and we left out the A function and went to what? B. We left the B function And we what? Went to what? C. All right. Now we in C. Say we complete everything in C, all of the statements. Where will the execution of the program return? To the main, to A, to B, or where?
Go back to B. Go back to B.
Have to go back to the calling function. So what function will C call from? It has to go back to B. It goes back to this next line here. If there's nothing, or it return back to the calling function. So from B we go back to what? A. There's no statements here. We go back to what? Main, and then here, and we end. Everybody understand that? Everybody got that? Now, given these functions, main, A, B, and C, I could have written it to where we had something like this. So what happens here? What we done? What have we just done? We're in Maine. From Maine, where are we going? To A. We go to A, and then what? We finish A, and we return it where?
Main.
Back to the main. In Maine, we're gonna return from here back to what? This next executable statement from A. Then what we're gonna do? Call what? B. So now we're gonna go from here to B, and we're gonna execute what's in B, and then we're gonna return where?
C.
Back to main.
There's no C in here. We're gonna return where?
Back to main.
Back to the main. All right, so we're gonna go to the next statement, and we're gonna call what? C. Execute this, and we return back where?
C.
We in C. Back to the main, and we finish. So the first example, left main went to A, left A went to B, left B went to C, then return back to B, then return back to A, then return back to main, right? This scenario, we execute the main, we went to A. We had to return back to main, then we went to B. Then we returned back from B to main, and then we went to C. And then we returned back to main, and we end. So you see there's different scenarios. Yes, ma'am?
Why was the scenario different?
Because of the way we call the functions. You got it? It's just the way we called it. Remember, in the first time I just had A here. Remember? And then what? I had B in A and C in B.
Because they were in different modules?
Right. So it's like A called B, B calls, main called A called B, B called C. That was the first scenario. But then you have to return back to the different modules to return back to the main. In this scenario, A, B, and C are all being called from where? The main. So what? Each one is a statement to be executed. So I execute the first statement, go to A, perform those tasks. I have to return back, return to the next executable statement, execute this, I go to B, perform what's in here, return back, the next executable statement, call C, perform what's in here, return back to main, there's nothing, we end.
Okay, so with modules, they always have to go back to main.
Eventually you gotta end up in main. But you always go back to the calling function, right? It's kind of like, I'll give you an example. What's your name, Miss what?
Connor.
Miss Connor, Miss James,
Smith.
Miss Smith. If I call on Miss Connor, right? Miss Connor calls on you, then you call on Miss Smith. In order for me to get verification, Miss Smith can't just come back to me. What I have to have? She got to go back to you.
And I have to go back to
Miss Jane, yeah, Miss Connor, and Miss Connor have to come back to me. You got it? Now, if I called on all, well, and that's kind of funny, all three of y'all, or if I call on Miss Connor, just Miss Connor, she would return back to me. Then I could call on you, then you can return back to me. Then I could call on Miss Smith, and she can return back to me. That's the last one. You understand what I'm saying?
Yeah.
Right, so that's how it works. You have to return to the calling function, all right? And that's how functions are. All right, so a hierarchy chart. In your first course, the 192 course, 2-3 course, you dealt with flow charting, all right? With flow charting, we flow charted the logic, correct? A hierarchy chart does not chart logic. It charts the relationship between the modules, okay? What module is calling what? That's all it's dealing with, all right? Now, so if we look at this hierarchy chart here, okay? Miss Jane, from the main, what functions are being called from the main function?
Get input, calculate gross pay, calculate overtime, calculate withholdings, and calculate net.
Correct. It shows the relationship between the modules or the functions that are being called. Now, does that mean that's the correct order? No, the order could be any order, but at least we see the what? The relationship. Now, but when we see get input has two what? Two functions that it's calling, right? But the main is not calling them. What function is calling them? Get input. So from the main function, when I call get input going to turn call what? Get hours worked, and then it's gonna call get hourly rate, pay rate. You understand?
So with that means that the hourly pay rate has to go back to input.
Correct, that's right. So once I grab the hours work, it has to return back to get input. Now, like I told you, the hierarchy chart does not tell you which function is executed first, because you can get the what? Hourly pay rate before you get the what? Hours work, either one. But once you complete the two, whatever order they're in, you're gonna return back to what?
Yeah.
Correct. And then get input going in turn return back to the main. So you understand what's happening. So those group of statements that's in get hours work gonna be dependent on the call that's coming from the main going to get input, and from get input getting to that function. All right? But then if we look further down to the right, we see that calculate withholdings have two modules that it calls. One of them that does what? Calculate the taxes, and the other one that calculate benefits. And that's gonna be probably deductions from the check, because it's withholding, right? So once you calculate those, in those two, you're gonna return back to what? Calculate withholdings, which in turn returns back to the main. Now, as we said, the hierarchy chart does not show the order in which the functions will be executed. But you as a programmer, looking at this, you know that there should be what? Some order in which you should have to follow. Correct, class? All right, so like I say, when you start writing your code, because what? I cannot do a calculate next function calculate net pay before I do what? Get input, right? I have nothing to be calculated, right? Because I haven't even inputted anything, right? So those things will be done when you actually what? Writing the code and setting it up in what order that you're gonna call them. But the hierarchy chart does not reflect which one is called first, if they're on that same level, right? Okay, but that's a hierarchy chart. Everybody would be able to create a hierarchy chart if I gave you that for an assignment. Huh?
Yes, indeed.
Everybody would be able to create a flow chart with modules in it, where you do the main and then you do the module flow chart, right?
Give us an example of one.
Yeah.
It's right here. Oh, you want to create? You want
It's
to
a
do?
hierarchy chart, not a flow chart.
Oh, a hierarchy chart? Okay, I tell you what. Let's take the example. Let's take this example first. All right. Let's take that example first. So what I'm gonna do? Pick up the screen. All right. So Mr. What? Mr.
Tucker,
Huh?
Tucker,
Chuck? What is?
Tucker.
Tucker, come up to the board, Mr. Tucker. We gonna work with you. We all in this together.
Alright, well,
No, but we gonna do.
using the modules, we can easily make a hierarchy chart off of that. I'm talking about a flow chart using the modules too.
Oh, okay, all right. But let's look at this. So let's take this example. So we have our main, which calls what? In our main, we're calling what? A, B, and C. And from that, we're not even calling anything else, right? So how would we write that? You could write on here, on this side. Don't write on there. Right over here.
Go.
Yeah, so draw a box for your main, or your main function. Man, I guess that's good, yeah. All right, put main in there. All right. Now, what are the relationships of A, B, and C to main? Right. You're gonna have 3 branches coming from main, going to A, going to B, going to C. Because all of those are related or being with what? With main. So draw
So
your
if
line.
you're using modules, you can't even make a flow chart.
Yeah, you can make a flow chart. This is just a hierarchy chart, remember? So draw your line down from the middle of main. All right, now draw a line going across. Yeah, going across. Now put 3 lines going down. And then what? Make your box for each one. You don't have to be that big because just A, B, and C. Don't connect it. Yeah, they don't do that. Yeah, there you go. All right. And right there. So, and what modules are we calling? A, B, let's see. That's this, right? The relationship of A is in main, B in main, C. A, B, and C does not have any relationship because they're not calling from one another, correct? Everybody got that? Now, look at that hierarchy chart. What I'm gonna do is, I'm gonna take this, give me your marker, and I'm gonna rewrite this the way we had it before. You stay there. All right, so now, come over some. So let's look at this one. All right, same code in a sense, but we what? Our modules are being called differently, right? So do our main. What functions are being called from the main?
It's only A.
All right. Okay, now looking at A. What functions are being called or is related with A? All right,
So how to do that?
come down. It's another level. Remember, just like what we had in the note in the book. All right. Then from B, what? So you see, look at the same code in a sense, right? We didn't change code because we just used module, but they could have had the exact same code in them, right? One module have all of the functions related to the main, whereas this model have the functions A, then B, depending calling from A, then C call from B. Everybody see that? Yes, ma'am.
So that's how it is in like flow chart form?
No, that's.
This hierarchy.
All this stuff.
This hierarchy. Now, the thing is though, once in the second one, once the module C is completed, where do we go back to?
Main.
You have to go back to B. You see what I'm saying?
See that but when you do your flow chart and you just say what A, B, and C are, then you'll see where you're going back to each one with that return thing on the flow chart.
Well, the return will take you just back to the executable
Right, so if you were
state.
flow charting this and you had like C and then it said whatever C said and then it would say return and then that.
But that's all it would say though.
Back to B.
But you don't know it. It'll just say return.
Okay.
But you as the programmer would know from where it's being called from where it return. Right. And we'll look at it. So in the second one, once C is completed, it has to return back to B. Once B is completed, you have to return back to A. Once A is completed, you return back to main. What's that?
You go to B.
No, that,
But
but,
A.
no, but you don't put that.
You just said that.
No, but that's understood. See, what happens is, this is where you're going with the logic. And the return just takes you back here. Return takes you back here. Return just takes you back. You don't have to rewrite, this. It's understood that C was called by what?
B.
And you always return to the calling function. B was called by what?
Okay. A.
And you always return to the calling function. A was called by what? Main, and you return. Look at this one, look. They're different. A is called by what?
Main.
You return back where?
To main.
Right.
But
B
they
is
were all called by main.
correct, and you return. So you see how the logic is different, even though the coding is the same. The statements are the same, but the logic in which you perform is different.
All right.
Now let's do a flow chart. Might be best to see if I can find one in the book.
Yeah, we have like 3 minutes.
Yeah, let's find. Huh?
We have like 3 minutes.
Oh yeah, we'll do it. All right. So let's
Next figure.
huh? Okay, yeah, okay.
There you go.
All right. So Mr. What's your name again? Forgot. What's your name?
W.
Last name.
Tucker.
Tucker. You said that last time? You told me something else, huh? Oh, you said Tucker? Oh, okay. I don't recall. Tucker. All right. So look. Let's look at this. All right. Mr. Tucker, let's look at this. I'm gonna erase this over here.
All right.
Now. Whoa. All right. So if we look at this, all right, our main functions, int main, right? That would be our code, int main, correct? Our main function will start here, and our main function will end here. All right, so what's in the main function?
Everything.
Huh?
All of it must be.
Right, so what we doing here? We calling a function named what? Starting method, all right? Now, let me ask you this. I didn't look at the next page. What is starting message doing?
It's giving the
No.
user a prompt.
No, but I'm saying we really don't know, right? Because it doesn't say, but that's the function. It could be 100 lines of code. It could be 2 lines of code. But you don't put the code here, you just put that call, okay?
This would be after the main. Yeah.
Correct, there you go.
Function.
Now you got it. It's gonna be like a start, stop with the name and then return.
Yeah.
All right, so all you do is put the function call. Now, here we're saying display, press a key to see step 1. That's our output. Then we saying read in the input. All right. Then we calling what? Another function called what? Step 1. Okay. So we calling another function. But when we called this function, we went somewhere and did what? Executed some statements, right? And we returned back. And then we did this, we did this. Now we said, okay, call step 1. Go to that step 1 function, do what you gotta do, but return where? Back here. You continue, all right? Display, press a key to see step 2, input the number 2. Or input, it just say input, so you just input. Then it say what? Call step 2. I'm gonna go execute step 2, I'll return back. But then it says what? Display, which is output. Press a key to see step 3. All right. Then it goes input whatever key you press, and then it goes and says, okay, go and do whatever in step 3, and then return. And then it displays. Press a key to see step 4. Output. It goes to the output input. It input the value. And like I said, just any key because it's just saying input to continue. And then it goes to step 4. What happened to my line here? So it's missing my line. So it goes to step 4, executes step 4, and it returns, and then it what? Stops. So this program, in a sense, allowed a person to pause the screen to see 4 different steps, basically, right? Now, we flowcharted the main function, but we never flowcharted the what?
The definition.
The definition of the module. Correct. So if we go, I'm trying to use this. So if we go down here, let me ask you this first of all. How many different sets of logic we should have?
6.
Main. This is main.
Okay, so 5.
1, 2, 3, 4, 5. Right? So we should have 5 different start stops, right? Our start terminal, stop terminals. So if we look here, we have what? 1, 2, 3, 4, 5. Now, you say, well, what is all that? How, whatever? The name of the function, what it's doing, return. The name of the function, what it's doing, return. The name of the function, what it's doing, return. The name of the function, what it's doing, return. The name of the function, what it's doing, and return. We don't care about where it's returning because we know based on our hierarchy chart, once we do a hierarchy chart on it, we know where it's going to return. Correct? So that's why, it's understood you go back to the calling function. All right? Any questions, class? Questions? All right.
Any assignments?
Be looking for one. I have a workshop tomorrow though, and so I'll be going to New Orleans early in the morning. So I don't know if I'll try to put something tonight, a program tonight. I'm gonna see. Yes, sir.
You gotta put a